Okay, hello everyone. Now we will start with the second panel of this afternoon with the topic of how to improve effectiveness of deep geothermal energy for heating applications. And we will have 3 talks this afternoon that will basically cover almost the whole range of a geothermal project. We will start with exploration, then we will go into deployment, and then later also learn about the long-term operation of a geothermal well, what we can learn there. So the first talk will be by Alexandre Stopin. He's a geophysicist working for BRGM, and he's responsible for the geophysical acquisition and processing of the Geoscan data project, and he will tell us now a bit more about greenfield exploration.
Thank you. Indeed, I will talk about the Geoscan projects. They have been mentioned this morning by some of the different speakers. And I present that on behalf of the Geoscan teams. There's quite a large number of people working at it on BRGM, from geophysicists, geologists, and petrophysicists, and also the people who helped us to do that project. The IDM has paid a lot of money for the acquisition that you're going to show, nearly 5.5 million of euros. But there are other sponsors that have helped us quite a bit. It's basically the Région Île-de-France who pays for all the scientific works that the BRGM is doing, not all, a part of it, 70%. And that's for Geoscan Île-de-France. And for Geoscan Arc, we have the Région Sud, the Département des Bouches-du-Rhône, and also La Métropole Aix-Marseille-Provence, who also pays 70% of the work. And the 30% remaining of all the scientific work that the BRGM is doing is paid by the BRGM itself. So today we'll present the 2 Geoscans projects, Geoscan Île-de-France and Geoscan Arc. These are the areas that are favorable for explorations for geothermal in France. I think we have seen that map a few times this morning. Most of the concentration here is in the Paris Basin, also a bit in the Aquitaine, and in the southeast of France. There is only one here in Montpellier, but not much else. But there's clearly a need to get more. We have seen the targets for geothermal exploration, for geothermal heat. There's quite large, so we need to understand the subsurface a bit better. And for that, we can use legacy data, but there's also a need to acquire new data in areas where there's not much, or in areas where we think that the new data is not enough. So for that, IDEM launched the program, the Geoscan program, together with the BRGM, and founded 2 of this program west of Paris, and also the Geoscan Arc, which is over here. Those projects are for 2 years, so they are going to finish for Geoscan Île-de-France by the end of the year, 2025, and Geoscan Arc around 2026 in June or so. All the data will be public for collectivities or for interstrials. The data that, so the new acquisition data, but also some of the reprocessed data that have been acquired, but also geology interpretations and things like that. Before we go further, I would like to show you a bit where the regulators and where the developers do invest. So usually we want to have we have different scales of explorations. Normally, what we think, the view is that the state normally should invest at regional or local scale, so with first geological studies, 2D regional lines to understand a bit more what the basin is, and then we focus further and further. And at the end, when you think about a project scale, a doublet, maybe with 40 square kilometers or 20 kilometers square, maybe 2.5 Ds or a few lines, that's more for the developer to actually do that work. Sometimes with the help of the states. We have seen the presentation of Norbert this morning that can help with that. So this is where we are. And the Geoscan project is basically sitting right here, where the scale is around 1,000 square kilometers for both projects. Yeah? The one in Paris is a bit larger, it's 2,000 square kilometers. So we have seen the Paris Basin. Actually, we are looking at more than the Dogger. The Dogger is usually the aquifer, which is the target for most of the doublet. But we have other reservoirs that could be of interest: the Albian, Neocomian, Oxfordian, and a bit below the Triassic. So it's a big. So those are the 5 aquifers that are targeted, and you can see that most of the geothermal operations are taking place in the east and the southeast of Paris. But there's a big gap over here. And we have seen the numbers already. We have 58 doublets, and nearly 1 million people are heated in the Paris Basin with geothermal, which is a very large number. So this is what we have as legacy data. We have lots of legacy data. In the 80s, oil and gas exploration in the Paris Basin. And, well, the only place which is actually being exploited is somewhere there in Melun. Yeah. But over here we have nothing, but you have lots of data. And the idea for the Geoscan project was to reprocess most of the data. So that's 1,600 kilometers that have been reprocessed and is going to be reinterpreted. But you also acquired new data over here. Well, we don't see them. We're going to see them on the next slides. And we have been using also lots of oil and gas wells to get all the logging informations in order to be able to get petrophysics, construct rock physics models, and after that do quantitative interpretation, which is something which is done very often in oil and gas, but not so much for geothermal. With that, what we would like to do is to be able to get porosity, and if we have a CAFI, then we can also get maybe permeability. To do that on legacy data, that's a challenge, so that's why we also wanted to acquire new data to show that maybe with new data you can do that. So we'll know that in a few months if that works or not, but at least that's the idea. So the project is a fully integrated geothermal resource exploration progress with data collection acquisition, some data processing of old data, interpretations. We are at that stage now, and then we're going to integrate also all the petrophysics information, and then basically get to a reservoir modeling of this complete area. As I mentioned, the old data is lots, but we also acquired 260 kilometers of new data, which are acquired by the company S-Cube. And for that, we used data with 65,000 pounds vibro truck, which is quite heavy. We had a sweep that started at 2 hertz, so 1.8 hertz exactly, up to 96. So it's very low frequencies, which is very important for QI. And a source point every 10 meters, and a geophone every 20 meters. That's extremely dense compared to what we used to see in the Paris Basin. We also do the CSCM survey right there, over here, in order to see what sort of data, complementary data, could electromagnetic methods provide in this context as well. It's a bit more researchy, but we think that combination of methods is the only way to actually get more information about the subsurface. So how was it done? Well, how was it done? You know, if you have seen that it's a very dense area. We're basically close to Paris. You see that we actually entered into Paris. That was the pictures that I showed right in the at the beginning of these presentations. So we had 98 cities that were involved in the process. We had 7 departments of the main roads, several national forestry, some private owner that needed to be involved in this project in order to get all the permits to get in there. So first we draw a theoretical lines to say, okay, we would like to go somewhere there. That's what you do on a GIS very quickly, and then afterwards you zoom a bit more. You see that you have a road, and then you see that you would like to go through there. Yeah, you refine the outlines, and then you look at all the networks that do exist, so gas and water, etc. You look at the sort of pipes that you have. Is it something solid? Is it something which is it cast iron? In which case, then you have different distances of for security. Some infrastructures, some of maybe the buildings are not very solid. They have different distances and accelerations that they can take when the truck comes. And then the vibrating strengths afterwards. And so basically you say, well, okay, this is the point where I'm going to do the vibration. So from theoretical lines down to the exact place where you're going to do the work, there's lots of work that need to take place in order to know exactly the position to the meter where you're going to do your vibration. And at the end, this is what's happening. You see the truck, which actually is right there, vibrating at the point. Yeah. So that you need to do that over the 260 kilometers of lines. So was it worth it to do? That's an example of some of the pre-processing that was done. The 82HP008 line is an old 2D seismic line which is collinear with one of the new acquisitions that we did. We did that on purpose in order to be able to compare both sort of acquisition, and this is one of the pre-processing of the 24IDF02, which is a new line. And what is already clear is the fact that there's a bit more continuity on the reflectors. You see more of them because we are higher frequent. And you see a bit more character. You see more black, more whites compared to just the wiggly effect that you can see on these ones. So the dogger is somewhere, I don't see, somewhere over here. This is the frequency spectrum. Basically tells you the richness of the data that you have, and clearly we have a bandwidth which is twice as much as what we see on the red one, which is the old data set. We gain nearly 2 octaves in the lower end, which is very important, because that always, again, that will give you more information for the QI. And then we have the other project, Geoscan Arc. Well, Paris Basin is very easy. It's relatively flat. There's not much. If you want to see an outcrop, you need to drive quite a few kilometers away to get to see the rocks. But in Geoscan, in the Arc Basin, basically this is the sort of structures that you see very quickly. Here we have the mountains. We have the Massif de la Nerte, and here Massif de la Nerte is over here, and here you have L'Étoile and Lafare. The rocks that are outcropping over there, they are basically 1 or 2 kilometers or 3 kilometers down there. Those are the targets. So lots of structure, deeps at 20 degrees easily. So for that one, we need to use also the same sort of acquisition, but instead of having just 1 truck, we double them twice because the subsurface is very hard. So if you want to get more energy in the subsurface and it's deeper, you need to put quite some energy. We also have, as you may notice, we also have some water right in the middle of the survey. And we also did a transition and acquisition with a source with 8 air guns. And we have continuity between the land and the water, meaning that the geophone which sits here is going to record the pop from the air guns, and a marine node which is at the bottom of the étang bear will also record a vibro track vibrating somewhere there. So this an acquisition where we have 4 sorts of data basically. So air gun to nodes, air guns to marine hydrophones, and vibrator to geophones, etc., etc. 260 kilometers of land and 60 kilometers of marine. Everything was done in 5 weeks only. But the permitting took 6 months to do. Because in order to get any sort of permits on the étang de Berre is very complicated, because you need to talk to the water regulations. You need to talk so there's some sort of a permit to get. You need to do a study. Is this going to affect the different sort of fishes that you have, the different sort of mollusks and palourdes and clams and stuff like that? How is it going to affect the fishing? Since we have an airport over here as well, if you put a flag, are the pilots going to be diverted to your acquisition, or are they going to land at the same positions still? So there are lots of things to be done. But yet 6 months to get down. Acquisition was finished at the end of November. And now we are at the processing stage. What we did, which wasn't done for the Ile-de-France, is lots of geology in order to understand what we see at the surface. There's already been done some projects and some studies. But since the targets are these ones, you can see at the surface. Yeah? So we have the late Cretaceous, but also the early Jurassic. So this is the Malm. And we see them outcropping. And since we have very few wells, and there's also oil and gas explorations, but the data is of much worse quality that we have in the Paris Basin, and we only have 3 wells with logs that are not that great and not targeting necessarily the targets that we want. We do lots of geology also to understand what could be the properties of the reservoir at depth. Lots of studies of the karsts, because this is what we think we have for the permeability and fracturations. So that's a big complement compared to the Ile-de-France. Another aspect on how was it done is all the communications that went around the 2 acquisitions, both for the Geoscan Ile-de-France and the Geoscan Arc. We spent lots of time communicating with the different cities where we were. We sent flyers. We had webinars as well to present geothermal energy. For the Geoscan Arc, we did Fête de la Science, where we presented it to school children as well, with demo of the vibro trucks in 2 cities. And in Versailles for Geoscan Arc, there were some programs on TVs afterwards, and also some newspapers. So we had lots of relay as well with the different communities that posted things on Facebooks and their local channels, and that really helped to get, let's say, a seamless, with not much, let's say, people complaining, an acquisition. No damages were done. The building is still standing. We had no issues, and that's quite good, because if you think about the urban areas where we operated, that was not necessarily easy at the beginning. So what's next for Geoscan Ile-de-France is to finish the structural interpretation. Actually, it's finished now. Now we want to do a cross-interpretation of the seismic data and the CSCM to see how we can combine them. And then the quantitative analysis of the seismic data, which is ongoing and should be finished in a few months or so. We hope that for the EAGE that will take place in Toulouse in June, for those who go there, then we can publish the result. And otherwise, that will be at the Journée de la Géothermie in Biarritz. And for the Geoscan Arc, that's processing of the data still ongoing, and then structural interpretation, finish the geophysical fieldwork, and at the end, indeed, construct a 3D geological framework, and then a bit of reservoir modeling. For this one, the QI is going to be a bit more complicated because the data is. If already we can see the structures, we're quite happy, I would say. But if we get quantitative interpretation, that would be the cherry on the cake. But I don't, even though we're trying to do it, I don't put big hopes on that one though. But it's very important still. So this is where we are, and I think it's nice to see that it has progressed so well. And normally in 1 year from now, we should have all the results for both projects. That's it. And if you want to see you want to follow us, then. You can scan this QR code, and you should end up on the Geoscan website, where we do post updates regularly on the projects. All right.
Thank you very much for these interesting presentations. We will take questions